Okay, this is the P2 paper from January 2023. It's question number 8, and this is a trig identities and equations question. Let's have a look at it. We've got one answer that's going to be in radians, one answer that's going to be in degrees. Let's jump straight in. And part 1 says, can we solve for this range of values 5 sine 3x plus 0.1 plus 2 equals 0. So first of all, I'm actually going to focus on the bit that I've got ringed there. So part 1, if we've got that x is between pi and minus pi over 2, what I've got to do is to take account of the fact that I've got 3x plus 0.1 here. So 3x plus 0.1 there would then be, or 3 pi plus 0.1 and minus 3 pi over 2 plus 0.1. Those two work out to be that 3x plus 0.1 then will be between 9.53 and between minus 4.61. So I'll return to that when I'm actually looking at the answer to the question. The question says this thing here, 5 sine 3x plus 0.1 plus 2 equals 0. So let's do that. So 5 sine 3x plus 0.1 plus 2 equals 0. So I now just need to solve this, just rearranging. So 5 sine 3x plus 0.1 is equal to minus 2, which means that sine 3x plus 0.1 is equal to minus 2/5. I want to find all the solutions to that. So the way that I do these is to say I'm interested in the acute angle alpha such that sine equals 2/5. Not the minus 2/5. I'll take care of that with my cast diagram, which we'll explain very soon. But first of all I want to work out is what alpha is going to be. So alpha then works out to be equal to 0.41. So what that gives me, so using the cast diagram, is the idea that what I've then got is in my quadrants here, alpha can be any of those acute angles there, as in 0.41, 0.41, same over here, and same over there, but I'm aligning that with the cast diagram, all sine, tan, cos. Hopefully you've seen this before. If not, you might need to go back and do some more revision. This says that all of the ratios are positive there. Sine is positive in here, tan is positive in here, and cos is positive in there. The ones that aren't marked then are negative. So for example, in this quadrant, cos and tan are both negative. In this quadrant, sine and cos are negative. Hopefully you've seen that before. Okay, if we're now saying then that sine 3x plus 0.1 equals minus 2 up there, minus 2 over 5, sorry. If we're saying that that's true, then I know my answers are going to be where sine is negative. Where is sine negative? Sine is negative here and here. Those are my two angles that are going to produce negative sine. Now, how do I get to those two angles? Well, I'm going to say that first angle then is there, and that's pi plus 0.41. So what I can say from that is that my 3x plus 0.1, I'm not even looking at alpha now, is going to be equal to pi plus 0.41. The other answer that it can be, get rid of that one there, is the other angle is this one all the way around there, which is 2 pi minus 0.41. So those are two of my possibilities. Let's just move this over a bit actually, because I'm going to need more values. It's those two answers then, or anywhere else that fits into the range. And remember, for 3x plus 1, my range is anything from minus 4.61 all the way up to 9.53. So if it's those ones then, those two angles could also be represented by minus 0.41 and whatever that angle there is, it's minus 2.72. I've already done it. So it's also equal to minus 0.41 and minus 2.72. And actually what I can now do is change these ones and make them to the decimal equivalents, which was 3.55 and 5.86. So those are the four answers that fit within this range. Okay, if I try and look at any bigger ones, let's just take, for example, that first angle here, this angle. Yeah, it's pi plus 0.41. It's also that answer with 2 pi added on to that, but 2 pi added onto this thing takes it outside of my range. It takes it bigger than 9.53. So if it's bigger than 9.53, it doesn't work. Let's say if you can go through and do all that work. These are the only four that actually fit into the range of values they've given me within the question. So for each one of those, if that's 3x plus 0.1, so let's change that color back. If I want to work out what x is, I'm just going to do minus 0.1 and then divided by 3. Minus 0.1 divided by 3, minus 0.1 divided by 3. So if I do all of those, then the four answers that I actually come up with for my final set of solutions is minus 0.94, minus 0.17, 1.15, and 1.92. Everything, I didn't really mention at the start, but everything was asked for to 2 decimal places up there. If you're not sure about that, you might need to go and have a look at some of the other questions that I've done within the P2 trigonometry. Let's keep going and do part 2 then. So part 2, completely different question, says, can we solve between 0 and 360 this time? So no real messing around with my range of values. Can I solve between 0 and 360? 2 tan theta sine theta is equal to 5 plus cos theta. This time we want the answers in degrees and we want them to 1 decimal place. So change your calculator over to degrees, be careful. Change your calculator over to degrees, part 2 then. So what have we got? It said 2 tan theta sine theta is equal to 5 plus cos theta here. So the first thing we're going to do is to use the identity that tan is sine over cos, isn't it? So if tan is sine over cos, I'm going to put that in here. So I'm going to get 2 sine theta over cos theta. Sine theta, is equal to 5 plus cos theta. And you say, right, okay, I can see what's going to be going on when I'm doing this. I've got 2, just do it slowly, 2 sine squared theta over cos theta is equal to 5 plus cos theta. Now let's multiply everything by cos theta to get rid of the cos theta on the bottom. I'm going to get 2 sine squared theta is equal to, multiplying all of that by cos, is going to give me 5 cos theta plus cos squared theta. And now here, I hope you've done enough practice of these. What I need to do is I need to change either sine squared to cos squared or cos squared to sine squared. But look, I've got a cos there. I can't change that very easily. So I want everything in terms of coses. And if I want everything in terms of coses, this can change using our second identity that sine squared plus cos squared is equal to 1. So if that's true, sine squared is 1 minus cos squared. So I'm going to get 2 lots of 1 minus cos squared theta is equal to 5 cos theta plus cos squared. Okay, this is going to turn into a quadratic. Let's tidy this all up. 2 minus 2 cos squared is equal to 5 cos theta plus cos squared theta. That turns into the quadratic 3 cos squared theta plus 5 cos theta minus 2 equal to 0. And then we try and factorise it. You could use a quadratic formula, but I'd always try and factorise it first of all. This one does factorise out. If you're not very good at these factorising, go back and practice them. Plus 2 equals 0. So I'm going to get cos theta equal to 1/3 or cos theta equal to minus 2. It's a really nice question with the sorts of answers that we quite often get here in the fact that this one has no solutions. They do that quite often to try and get rid of some of the answers for us here. So I've just got cos theta equals a third. If cos theta equals a third, the way that I do it, exactly the same, I'll do it really, really quickly this time with the cast diagram, is say, okay, if cos theta is equal to a third, then where are my possibilities for the answer? All, sine, tan, and cos. Where am I going to get cos being positive? Here and here. So if I work out my little alpha again, this acute angle here, cos alpha equals a third, gives me alpha equals 70.5 degrees, which means that this angle is 70.5, this angle is 70.5, and in the range of values that I want, I'll just move this out of the way a little bit, in the range of values I want from 0 to 360 degrees, so my answers are going to be 70.5 and that angle all the way around there, which is 360 minus 70.5, so I end up with my actual answers, working out to be that theta will work out to be 70.5 and 289.5 degrees. Let's just change the colour on that. Gosh, let's change the colour on that to that. So that's the way that we go through and do this equation. We get those 2 answers and those 4 answers. Hopefully that all makes sense for the trigonometry for P2.